Good morning, all of you. Today we will be discussing the second property, which is commutativity. And first, we will be discussing it with whole numbers. Okay. So, basically, what do you mean by commutative property? Commutative property means what? If A plus B equal to B plus A. That is basically commutative property. Okay. That means first we will be discussing it in the case of addition. Okay, in the case of addition, if suppose A and B are any two whole numbers, and if A plus B is equal to B plus A, then we can say that they are commutative. Okay, that is A plus B equal to B plus A. This is the basic thing in commutativity for addition. Okay, now let's check it with whole numbers. Suppose I am taking the number 0 and 5 and I am going to add it. So you know that what is 0 plus 5? 0 plus 5 is 5. Now I am changing the order and adding it. That is 5 plus 0. Then again the answer will be 5. Okay, that means what? A plus B equal to B plus A. Okay. Now let's take any other number. For example, 3 plus 4. What is 3 plus 4? It's 7. Now what is 4 plus 3? That is I am changing the order. 4 plus 3 means it's again 7. That means you can say addition is commutative for whole numbers. Okay, for whole numbers addition is commutative. Why? A plus B equal to B plus A. So you can say that addition is commutative for whole numbers. Okay. Now let's see what is the case with subtraction. Okay. Now for subtraction, I am taking again 0 and 5. So I am taking 0 and 5 and I am subtracting it. Then what is 0 minus 5? That is 0 minus 5 is what? Minus 5. You know that. Is it? Now I am changing the order and subtracting it. That is 5 minus 0. What is 5 minus 0? It's 5. So here these are not equal. That is minus 5 is not equal to 5. Okay. Now I am taking any other number, that is 3 and 4. What is 3 minus 4? You know that 3 minus 4. How will you do that? 3 plus minus 4. What is 3 plus minus 4? It's minus 1. Okay. Now I am changing the order and subtracting it. That is 4 minus 3. What is 4 minus 3? It's 1. So here it's minus 1 and here it's 1. So they are not equal. They are not equal. Okay, so what can you say? You can say that subtraction is not commutative for whole numbers. Okay, subtraction, in the case of subtraction, it's not commutative for whole numbers. Why? Because A minus B is not equal to B minus A in this case. Okay, if A and B are whole numbers, then A minus B is not equal to B minus A in this case. So you can say that subtraction is not commutative for whole numbers. Now let's see what is the case with multiplication. So I am taking two whole numbers 0 and I am taking 5 and I am going to multiply it. So what is 0 into 5? You know that it's 0 itself. Now I am changing the order and multiplying it. That is B into A. What is 5 into 0? It's again 0. So both are equal. That means A into B is equal to B into A. Okay. So you can say that multiplication is commutative for whole numbers. Okay. Now let's take another example. Suppose 3 into 4. What is 3 into 4? It's 12. Let's change the order and multiply 4 into 3. What is 4 into 3? It's again 12. So both are equal. Okay. So A into B equal to B into A. That means you can say multiplication is commutative for whole numbers. Now let's see what is the case with division. Okay. I am taking the numbers 5 and 3. Okay. And I am going to divide this 5 by 3. So what will be the answer? Answer will be 5 by 3. Okay. Now again I am changing the order and dividing it. That means 3 divided by 5. So what is 3 divided by 5? You know that it's 3 by 5. So the first answer is 5 by 3. and the second is 3 by 5. So you know that both are not equal. Or you can say that A by B is not equal to B by A. Okay, that means division is not commutative for whole numbers. Okay, that is the case. You can take any other examples, the answer will be the same. For example, I am taking 1 by 2, 1 divided by 2. The answer will be 1 by 2. Now what about it's 2 divided by 1? It will be 2 by 1, which is equal to 2. So the first one is 1 by 2 and the second one is 2. You know that both are not equal. Okay. So you can say that A by B is not equal to B by A for whole numbers. Or you can say division is not commutative for whole numbers. Okay. So this is the case for whole numbers. Okay. So let's conclude. So this is our conclusion, that is addition and multiplication are commutative for whole numbers and subtraction and division are not commutative for whole numbers. Okay, that means addition and multiplication is commutative means what? A plus B is equal to B plus A for whole numbers, and multiplication means what? A into B is equal to B into A. Okay, now what about subtraction and division? A minus B is not equal to B minus A. And what about division? A by B is not equal to B by A. Okay, so these are our conclusions. Okay, and you will see that the same result holds for natural numbers also. That means for natural numbers also addition and multiplication are commutative and subtraction and division are not commutative. Okay, you can check it by yourself. Now let's check the commutative property for integers. Okay, and the first thing is addition. Let's check it with addition. So I'm taking the numbers as minus 5 and I'm going to add it with minus 3. So what is the answer? What is minus 5 plus minus 3? You know that answer is minus 8. Okay. Now I am changing the order, that is minus 3 plus minus 5. Even if you change the order, you know that answer will be the same. That is minus 3 plus minus 5 is also minus 8. Okay. So you can see here that A plus B is equal to B plus A. Okay, now let's check it with any other number. 5 plus minus 2. Okay. What is 5 plus minus 2? It's 3. Okay, 5 plus minus 2 is 3. Now let's change the order, that is minus 2 plus 5. What is minus 2 plus 5? Again, here you have to do the subtraction and put the sign of bigger number. So answer will be 3. So both are equal, that is A plus B is equal to B plus A here. That means you can say that addition is commutative for integers. Okay, addition is commutative for integers. Now let's check what is the case with subtraction. Okay, so suppose I am taking the same number itself, that is minus 5 and minus 3, and I am going to subtract it. So how will you do that? Write the first number as it is and you have to add it with the additive inverse of the second. That is the additive inverse of minus 3, it's 3. So minus 5 plus 3. What is minus 5 plus 3? It's minus 2. Okay. Let's reverse the order. That is minus 3 minus minus 5. Okay. We are changing the order of this. So what is B minus A? Here we will write the first number as it is and put the positive sign. And what is the additive inverse of minus 5? It's plus 5. So what is minus 3 plus 5? It's 2. So in the first case we have got minus 2 and in the second case we have got 2. So both are not equal. That means what you can say, A minus B is not equal to B minus A. Okay, A minus B is not equal to B minus A. Okay, let's check it with other numbers. I am taking minus 2 and 5. Minus 2 minus 5. What is minus 2 minus 5? It's minus 2 plus minus 5. Okay, minus 2 plus minus 5. What is the answer? It's minus 7. Okay. Now let's change the order. That is 5 minus minus 2. Okay. So 5 plus, what is the additive inverse of minus 2? It's plus 2. So what is 5 plus 2? It's 7. So in the first case you got minus 7 and in the second case you got 7. So minus 7 is not equal to 7. Okay. So here also you can see that A minus B is not equal to B minus A. Okay. So what can you say? You can say that subtraction is not commutative for integers. Okay. In the case of subtraction, A minus B is not equal to B minus A. So subtraction is not commutative for integers. Okay. Now let's see the case with multiplication. I am taking two numbers, that is minus 5 and minus 3, and I am going to multiply it. So what is the answer? Minus 5 into minus 3 is 15. Okay. Now I am changing the order and multiplying it. That is minus 3 into minus 5. So what will be the answer? Minus 3 into minus 5. It's again 15. Okay. So both answers are the same. That means you can say A into B is equal to B into A in this case. In the case of integers. Let's take some other examples. That is, I'm taking 3. 3 into minus 7. What is 3 into minus 7? The answer is minus 21. Okay. Now I am changing the order and multiplying it. That is minus 7 into 3. What is minus 7 into 3? It's minus 21 itself. That means both answers are the same. Or A into B is equal to B into A. Or you can say multiplication is commutative for integers. Okay, multiplication is commutative for integers. Okay, understand? Now let's see the case for division. In the case of division, I am taking two numbers, 5 and minus 3 itself. 5 divided by minus 3. What is 5 divided by minus 3? 5 by minus 3. Now what about minus 3 divided by 5? The answer will be minus 3 by 5. So the first one is 5 by minus 3 and the second one is minus 3 by 5. So by seeing this, you can see that numerators are not the same and denominators are not the same. So they are not equal. Okay. That means you can say A by B is not equal to B by A in the case of integers. Okay. Or you can take more examples. Suppose minus 3 divided by minus 4. What's the answer? The answer will be minus 3 by minus 4, or you can say 3 by 4. Okay. Now I am changing its order and dividing. That is minus 4 divided by minus 3. So its answer will be minus 4 by minus 3, or you can say 4 by 3. So in the first case you got 3 by 4 and in the second case you got 4 by 3 and both are not equal. Okay. So you can say that A by B is not equal to B by A, or you can say division is not commutative for integers. Okay. Understand? Now let's conclude all the points about this integers: addition, subtraction, multiplication and division. Okay. Here you can see that addition and multiplication are commutative for integers and subtraction and division are not commutative for integers. Just the same result as that of whole numbers. Same result. Okay. Here also you can say A plus B is equal to B plus A and A into B is equal to B into A. What about subtraction? A minus B is not equal to B minus A. And about division, A by B is not equal to B by A. So these are the conclusions that we are getting for integers. So this is all about the commutative property for whole numbers and integers. Okay, I hope you understood this. And we will discuss about the commutative property for rational numbers in the next video. Okay, so that's all. Thank you.